All right, everybody. This is problem 18 of the AMC 10 Test B, 2018. All right, and so um, the problem here is telling us three young brother sister pairs from different families need to take a trip in a van. These six children will occupy the second and third rows in the van, each of which has three seats. To avoid disruptions, siblings may not sit right next to each other in the same row, and no child may sit directly in front of his or her sibling. How many seating arrangements are possible for this trip? Alright, and it gives us the answers: A 60, B 72, C 92, D 96, E 120. Alright, and let's figure out how to solve this problem. Alright, and so it's saying three younger brothers, sisters, blah, 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 blah. Where is it? Second and third rows in the van, okay? So we have one, two, three. We have three seats in each row. So one, two, three. One, two, three, okay? And all right, now it says to avoid disruption, siblings may not sit right next to each other in the same row. All right, so let's call each sibling. Let's denote a sibling with the same number, right? So sibling one, sibling two. All right, sibling. These two are siblings, one and one. These two are siblings, two and three are also siblings with each other, three and three. Okay. Now let's see how many seating arrangements are possible. Okay. So we can first of all we have three options for this one right here. Right. We can either go three, two, or one. So let's say we choose the number three. Okay. And now for this one and this one right here, we have two options, right? We can either choose two or one, right? Because we can't choose the number three because it tells us to avoid disruption, siblings may not sit right next to each other in the same row. Or no child may sit directly in front of his or her sibling, right? So we can't put three right here or here. So let's say we choose the number two, okay? We choose the number two. And now how many options do we have? Well, we have one option now, right? Or we no, I'm sorry, we have two options now. We can either choose a two or a one, right? Because if I choose a two right here, it's not directly in front or behind or next to it, right? Or if I choose a one, right, it's different from all of these. So I can choose, let's say I choose the number two. I have two options, I choose the number two. Now let's say now what about for this one right here? Well, I'm kind of forced to pick the number one, right? Because let's say I choose number three right here, right? If I chose number three, then I have to put one and one right here. And guess what? One is directly in front of the number one, so we cannot do that. Alright, and let's say, and I already ran out of my twos, right? So I only have one more option here. I can't choose three, I can't choose two either, right? So I have to choose the number one. So I have one option. So first we had three options, then we had two options, and then we had another two options, right? Two or one. Then we had zero options, right? We had to choose one. And then look, I have zero options again. I have to choose the number. I have to choose the number one right here, right? Because let's say I chose the number three right here, right? If I chose the number three, then I couldn't put my one right here, right? Because one and one are right next to each other, right? So I cannot do that. So I will choose the number one right here, and then I'll have three right here, right? So we have three times two options, right? So we have three options right here. We have two options right here. We have two options right here, and we're kind of forced to draw in numbers right here. Okay. So we have three times two times two. What's three times two times two? Well, that is equal to 12, right? So it says we have 12 options, we have 12 ways we can mix up these children when we start off with this seat right here, right? But remember we have oh whoa. We have four seats to choose from, right? We have four seats to choose from to start with, all right? So we multiplied that by 4, right? Because all we did was just set the amount of permutations when we start off with this seat, but we have four seats to start off with at the end. So we have times 4, okay? And now we have 12 times 4. What's 12 times 4? 12 times 4 is 48, okay? And so some of you may stop at 48, right? Because you know that you may think that's all we have, but what else we have here is, remember, 3 and 3. These are two different siblings, all right? And because we have a pair right here, 3 and 3 are two different sets of siblings, and 2 and 2 is a different set of siblings. 1 and 1 is a different set of siblings, right? We multiply it by 2, right? Because they're two siblings with each other. And 48 times 2 is equal to 96, all right? So this, we can put sibling 1 or sibling 2 in here. We can put sibling 1 or sibling 2 in here. Sibling 1 or 2, sibling 1 or 2, right? We can put sibling 1 or we can put sibling 2 in there, okay? So two sets of siblings and 48 ways you can mix up all of these in these 4 different chairs, okay? And then you get the answer 96. And fortunately, we have an answer 96 right here, which is the answer D. So, if this problem was a little hard for you, I suggest you rewind back to the video. Or, what I did, I had trouble doing these permutation, combination, probability problems when I was back in ninth grade. So I want you to just get used to combinatorics and probability, and these problems will get a lot easier once you learn those things. All right, there you go. That's how you do it.